Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage, resistors, electric power and energy. This exercise was a previous one in the brief exams in 2012 second session, second exercise. The title of this exercise is maximum voltage of a resistor. The aim of this exercise is to determine the maximum voltage Umax that a resistor D of resistance R can withstand. For this we set up an electric circuit formed of a DC generator G of adjustable value, the resistor D, a voltmeter V to measure the voltage U across D, an ammeter A of negligible resistance to measure the current I that traverses D. Then this electric circuit consists of 4 electric components and they are given by the DC generator G of adjustable voltage, the resistor D, a voltmeter V and an ammeter A. Part A, determination of R. Part 1. They are telling me draw a diagram of the corresponding circuit. Let's start by the DC generator. This is the DC generator. Because it is of adjustable voltage, then we draw this arrow. Okay, here we have the ammeter that measures the electric current across the electric component D, which is the resistor. And we connect it back to the negative pole of the DC generator. Now it's left to represent the voltmeter. So the voltmeter is measuring the voltage U across D. Then it must be connected in parallel to the resistor D. Now it's left to represent the COM terminal of the ammeter and the voltmeter. Since they didn't mention anything about the reading of the ammeter and the voltmeter, so we take them by default to be positive. So this is the negative pole. So the COM terminal of the ammeter and the voltmeter must be connected to the negative pole of the battery in order for both of them to give positive reading. This is the negative pole. So this is the COM terminal of the voltmeter and this is the COM terminal of the ammeter. Then this is it for part 1. Now in part 2 they are telling me, knowing U and I, give the name of the law used that must be applied to deduce R, and this is given by Ohm's law. They are just asking me about the name of the law, so Ohm's law. Now in number 3 they are telling me write the relation that expresses this law, and the relation is given by that U is equal to R multiplied by I. Now part 4 they are telling me the characteristic curve current voltage of D is given by the graph of the adjacent figure. They mentioned the adjacent figure, then now we can use it. Part A, give the value of the voltage U across D when it carries a current I is equal to 50 milliamperes. Then here we need to refer to this curve in order to determine the voltage U across D when it carries a current I is equal to 50 milliamps. So here we are referring to the given graph. Then let's say graphically. So they usually give a half a mark for this statement. Now for I is equal to 50 milliamps, we have that the value of U is equal to, now I is equal to 50 milliamps corresponds to this point on the curve. This is 50 milliamps, correspond to this point. Now let's locate 50 milliamps on the curve. It corresponds to this point on the curve that has a voltage given by U is equal to 5 volts. Then U is equal to 5 volts. Now in part B they are telling me deduce the value of R, and the word deduce means that we need to use the part just previously before. In part A we have the value of the applied voltage given by 5 volt when the resistor D is being traversed by the current I is equal to 50 milliamps. Then we can use Ohm's law, which is given by U is equal to Ri, in order to calculate the value of the resistance R. Here, no need to mention that we are using Ohm's law because we already did so in part number 2. Then let's construct the triangle of the following formula. Here, because we have multiply, then U will be at the top and R and I at the bottom. We are interested in calculating the value of R. Then R is given by U divided by I. Now the value of U is given by 5 and the value of I is given by 50 ohms. 50 milliamps. Knowing that milliamps is not the SI unit of electric current, in order to convert from milliamps to amps, we simply divide by 1000. Then dividing 50 milliamps by 1000, this will give me 0.05 amperes. So 0.05. Plugging this on the calculator, it will give me 100. Since U is in the SI and the value of I in the SI, so the value of R will be in the SI, which is ohms. Then R is equal to 100 ohms. And let me write this here, that R is equal to 100 ohms. Now in part B of this exercise, they are telling me determination of U max. Number 1, give the expression of the power P dissipated in D in terms of U and I. So the expression of the power P, the electric power in terms of U and I, is given by U multiplied by I. Now number 2, they are telling me show that P can be written in two forms. P is equal to U square divided by R and P is equal to RI square. So starting from the general form P is equal to U times I, we need to prove that P is equal to U square divided by R and P is equal to RI square. Let's start by P is equal to U square divided by R. So we need to prove this. Then notice that when comparing these two expressions, here the resistance R appear, and we know that by applying Ohm's law, we can relate the current to the resistance because the current doesn't appear in this relation. Then let's start by P is equal to U times I, and here between the brackets, let's say that U is equal to RI given by Ohm's law. Now here, because I doesn't appear in the equation, which means that we need to replace the value of I by U divided by R, which is equal to U multiplied by U divided by R. Now here we can get rid of the brackets because it's a combination between multiplication and divisions. So U multiplied by U divided by R, here divided by 1, which is equal to U square divided by R. Then P is equal to U square divided by R. So this is the second form of the electric power, which is given by P is equal to U square divided by R. Now let's prove the other form, which is given by P is equal to RI square. Now starting from the general form, which is given by P is equal to U times I, and here because R appears in the expression, which means that we need to use Ohm's law, which is given by U is equal to RI, and because U doesn't appear in the expression, which means we need to replace the value of U by RI, then R multiplied by I multiplied by I. Here we can get rid of the brackets because it's combination between multiplications. Then R multiplied by I, which gives me RI square. Then P is equal to RI square. So this is the third form of the electric power that we have already proved. Now in number 3, they are telling me, let me make some space. Knowing that the maximum power withstand by D is P max is equal to 1 watts. Calculate U maximum. Then we need to calculate the maximum voltage that this resistor D can withstand. So here we have the maximum power, which is given by 1 watts, and we have the resistance given by 100 ohms. We need to calculate U max. Then we will use this relation. Because we have the power and we have the resistance, we can calculate the voltage from this expression. Then let's use P is equal to U square over R. Constructing the triangle of this formula. Here, because we have divide, then P will be at the bottom. P will be at the bottom, and U square at the top, and R at the bottom. We are interested in calculating the value of U, so let's first calculate the value of U square, putting our hand over U square. Then U square is given by P multiplied by R. Now here U is given by U max and P is given by P max. Then we know that the value of P max is given by 1 watts and the value of R is given by 100, which gives me 100. So the value of U square max is equal to 100. But notice that here we are interested in calculating the value of U max and not the value of U to the power 2. So what we will do is the square root on both sides, which will give me that U max is equal to the square root of 100. Plugging this on the calculator will give me 10. Since everything in the SI, so the value of U max will be in the SI, which is volts. Then U max is equal to 10 volts. So this is the maximum voltage that the resistor T can withstand, knowing that the P max is equal to 1 watts. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.